From the beginning, Tabby's star defied expectation. In a galaxy where almost every star behaves with predictable rhythm, brightening, dimming, pulsing in patterns humans have cataloged for centuries, this one stood apart like a cosmic anomaly. Known officially as KIC 846-2852, it sits nearly 1,500 light-years away in the constellation Cygnus, a modest, unremarkable star by every traditional measure. And yet, in its light, astronomers found something astonishing: enormous drops in brightness, some fading by 20% or more, occurring irregularly, unpredictably, in ways no star should ever behave. It was as if the star were flickering behind a massive, shifting veil, one too large, too asymmetric, too chaotic to be the result of planets, comets, or dust alone. Tabby's star became a riddle woven into starlight, a mystery hiding in plain view. What made it extraordinary was not just the dimming, but the silence that followed each event. No heat emissions, no gravitational tugs, no rhythmic pattern to mark orbital objects. Just sudden, dramatic plunges into darkness, then a return to normalcy as though nothing had happened. These strange fluctuations captured the imagination of astronomers and dreamers alike, drawing them into a mystery that seemed to deepen with every attempt at explanation. The star resisted every simple answer. It whispered secrets through its light, but never revealed its truth. And so, a star that should have remained obscure, one among billions, became the focus of global fascination. It became a symbol of cosmic defiance, the first star to truly challenge our understanding of stellar behavior. The first star to hint that our universe may still hold phenomena beyond the boundaries of science as we know it. Tabby's star did not merely dim. It questioned everything we thought we understood about stars. When Kepler detected the first massive dip in Tabby's star's brightness, astronomers combed through the data expecting to find the usual culprits. A large planet, perhaps, a cluster of comets, a dense cloud of dust, but each explanation collapsed under scrutiny. The dimming was too deep to be caused by planets. No world, not even a super Jupiter with an enormous ring system, could block that much light. Comets would sublimate as they approached the star, leaving heat signatures that Kepler and other observatories would have detected. Even dust, the most forgiving solution, failed to account for the irregularity of the events. Dust dims starlight more in blue wavelengths than red, but Tabby's star dimmed almost uniformly. As astronomers dug deeper, they uncovered not a single mystery, but layers of them. The star had been dimming slowly over the course of a century, something no known stellar process could explain. On top of that slow fade came sudden drops, some lasting days, some weeks, none following any orbital pattern. The universe rarely produces this level of chaos around a stable F-type star. It was behaving as though enormous structures were drifting in front of it, structures that could stretch thousands of kilometers across, too irregular and too large to belong to any natural planetary system we had ever studied. The more the scientific community tried to make sense of the star, the more confused it became. Each hypothesis opened new questions. Each observation contradicted the last. Tabby's star became a case study in cosmic frustration, a reminder that sometimes the universe produces anomalies not because they are supernatural, but because our understanding is incomplete. Because the cosmos is far more varied, far more inventive in its mechanisms than we have yet discovered. As the mystery deepened, theories began to span a spectrum from the conventional to the fantastic. Some proposed that a massive swarm of comets, perhaps destabilized by a passing star, had begun spiraling toward Tabby's star in great clouds. Icy bodies so numerous that together they could dim the star in unpredictable waves. But such a swarm would require thousands upon thousands of comets, a cosmic traffic jam so intense it bordered on absurdity. Others suggested vast clouds of dust drifting between us and the star, but dust behaved in ways the dimming did not. And without a single unifying cycle, the dust would need to move with chaotic freedom across interstellar space, an improbable ballet of particles. Then came the idea that captured the public's imagination, the possibility of a megastructure, an alien-built construct, perhaps a Dyson swarm, partially surrounding the star. Not a fully enclosed Dyson sphere. The energy signature would be unmistakable, but an incomplete array of panels or collectors. Structures large enough to cause the dramatic dips, but scattered enough to leave the star's infrared emissions unchanged. Scientists did not leap to this explanation, but they did not dismiss it either. The data was too unusual, too resistant to conventional logic. For the first time in decades, a mainstream astronomical mystery allowed just enough ambiguity for the alien hypothesis to sit quietly at the table, not as an answer, but as a placeholder for the unknown. But science demands discipline, and even the most tantalizing ideas must bow to evidence. Follow-up observations began to indicate that the dimming was more consistent with tiny particles, microscopic dust grains, too fine to glow with heat, perhaps produced by the disintegration of bodies orbiting the star. A natural explanation, but not one that fully closed the case. To this day, the behavior of the star remains only partially understood. The explanations fit some data, but not all. The anomaly persists. Tabby's star remains, in essence, a cosmic question mark, an invitation for future discoveries to reveal mechanisms we have not yet imagined. In the end, Tabby's star stands as a reminder that the universe is not obligated to be simple. It does not owe us predictable behavior or easy answers. When we launched telescopes like Kepler, we expected to find planets, systems, and stars that obey the rules we understood. But Tabby's star taught us something more profound. It showed us that even among the billions of stars in the galaxy, there are objects that challenge our models, our assumptions, and our confidence. It reminded us that the cosmos is not a solved puzzle, but a vast frontier full of phenomena that remain hidden, misunderstood, or entirely unimagined. Whether its strange dimming is caused by dust, comets, or some process not yet conceived, Tabby's star forces us to confront the limits of our understanding. It asks us to look deeper, question harder, observe longer. It invites us to accept that mysteries are not failures of science, but the very reason science exists. Without anomalies, we would have nothing left to explore. Without the unexplained, we would have no reason to push our instruments further, sharpen our theories, or expand our curiosity. Tabby's star is more than an astronomical oddity. It is a symbol of the unknown, a beacon of uncertainty, a star that disrupts our tidy models and demands humility. In a universe of orderly orbits and predictable patterns, it stands defiantly chaotic, reminding us that the cosmos is still capable of surprise. That somewhere in its boundless expanse, there are still secrets waiting in starlight, quiet, patient, and profoundly strange. And perhaps that is the greatest gift Tabby's star offers us. A reminder that the universe is not done teaching us how much we still have to learn. A star that dims not to hide, but to invite wonder. A star that remains, even now, beautifully, frustratingly, unsolved.